In this movie, I'm going to perform the interpolations on my core data. This is for our ASM 540 project, but it's good information about interpolations for anyone. I'm going to use Modelbuilder, and in fact, I'm going to perform queries on the raw data set and perform all the interpolations I need at the same time. I've created a model in a toolbox. The toolbox is inside a geodatabase on my C drive in my C temp. I've renamed my model Interpolate. This gives me the advantage of being able to provide this to someone else by zipping up the geodatabase. In my big picture, I have a large data cloud. I'm going to clip the point layers to once inside of a river that I've digitized, and then I'm going to do three, basically these are queries. I'm going to use a definition to set the feature layers. In other words, I'm separating my data in terms of three different depths, and I can do that with a definition query and make that into an output layer, and then each output layer will be interpolated, yielding a raster of the values measured in the river. These steps have been performed by students already in our class, but this is actually another way to look at it. We could organize all the work in advance and step right through it in a single model. Well, I've populated my model, so I'm doing a clip. I'm using the river outline on a large core data set that will yield the cores that are inside the river, and then I split them three different ways. So they're coming in. The output has a name that I will be able to identify as being what depth they are, and I'm using an expression which is the same as a query, so that the only data I get is the data that answers this query. I do that all three times. So each one has a different query to get the correct depth layer data. One thing that I need to remember to do, I'd like to add these to the display. Also, I don't want them to be an intermediate layer because that disappears at the end of the model. So I uncheck intermediate. So each one of these three will be a persistent new layer and will show on my map. I then set up the IDW. The IDW parameters, to some extent, are already set for us, and we need to be very careful that we are going to interpolate based on the correct column. So all my data sets I'm interpolating based on PCB detect, which is the measured values. I have to be very careful I don't interpolate on a depth or a coordinate, which would be dumb to do that. My output layers, I give them a name that I can recognize which depth went to create this later. So I have, in this example, 0 to 3 feet is a layer, 3 to 6 feet, 6 feet to 9 feet. So I'm going to have layer 1, layer 6, and layer 9, so I can tell the difference. The cell size has been determined by our assignment, and I'm using in my model a fixed radius instead of a variable radius, and I'm setting 50 meters. How do I know it's meters? Well, these layers are UTM, and so that will be meters, which is an inherent unit in the UTM system. So what this says to do is to use all the sample points in a 50-meter circle, and that's what it'll use to get its interpolated value. I've done that to all three of these. I've been real careful to go back and make sure that I have PCB detect as my z-value field, that I've set the output cell size exactly the same, and then I'm using the same search radius. So I'm ready to run. I'm ready to save it and then run it. I guess I should discuss the results a little bit because I've determined that I made a couple of errors as I hastened through building this model. One of the errors is I forgot to assign the barriers at this step. The impact of that is that my interpolation is it's using all of the points within a 50-meter circle, and up here where my mouse is, you can see that this point and this point were interpolated together, and so there's a gradient between them. Whereas what I really wanted was for that barrier to stop the interpolation completely. So what's happened is we have these values in the main part of the river that are related to this point. I did not want that. So I want to redo this with my lines as barriers. Another thing that happened was, you see how this point, the color stops right at that point. The default extent of my analysis was the default extent of these points. I don't really want that. I want to have it go all the way out to the river, as in the example I just turned on. And in order to get that, I need to go in environment settings and set my river as the extent. And so then it fills out to the edge of the river. One of the things that I can see happening also is, let me turn off this other color here. And the first ones, I forgot to set a mask. If I don't set a mask, I get this. I get data outside my river being the blue lines. Absolutely cannot have that. If this point, for example, was higher than the legal limit and had to be dug up, according to this map, you'd have to buy these houses and dig them up too. And that's absolutely wrong, because all the contamination is in the river. So we must set the river as a mask in the environment settings for that tool. So I have to do that over again also. Last but not least, in terms of observations, when you use a 50-meter radius, if you have no point within 50 meters, you have no data, you have no interpolation. So in the future steps, we have to remember that we have spots inside of our area that have no data, and we will have to reclassify these, because eventually we're going to add together the three layers. And anytime I add together a layer with no data, it wipes out or refuses to add any data from any other layer. So any hole on one layer becomes a hole on all three layers. So the next step for us will be to reclassify these and fill that with zeros. Last but not least, in my queries, when I looked at the results I had, I realized that one of my layers had 461 cores in it. And it happens I know that's not correct. So I caught the mistake. But you see right here it is. When I made the definition query, my mouse slipped or something and I grabbed the column. I wanted start depth and end depth, and instead I got x coordinate greater than 6. Well, all these points have an x coordinate greater than 6 because they're in meters. And so the answer to this query is all of the points, which is not what I really desire. So I have to redo this. So for each of my tools, I need to make sure that processing extent and raster analysis are all set as they should be. So we have the extent set to the river. I'm not actually using snap raster. The point of that would be to make several raster layers line up. In raster analysis, we're setting the cell size at 5.49, and we're setting the mask as the river. So I have both of those. Last but not least, I need to make sure that I have the barrier set down here at the very bottom. You have to scroll down to get to it. So the shapefile we created, or the feature class we created as a barrier, needs to be input. So if I don't see that, I have to go back and get that. So now I'm ready to run this again, making yet another set of, well, you see that these I've saved because those were done correctly with the queries. This one I've changed the name in order to, actually I haven't changed the name yet, but I need to, because I'm going to run the query over again. And once I change that name, I have to make sure it's changed here, and it was because I have them hooked. So I'm going to get a new query at the 6 to 9 foot level. I'm going to run IDW over again 3 times. I'm going to have 3 new raster layers. These raster layers will be floating point layers. They will look like this. They'll have gaps where they have no data in the area that we'll have to take care of. The operation I have in front of me right now is the one that wraps up the analysis of our midterm project. I've created the IDW layers from the 3 core layers, as I described earlier in the movie. The last step, the last 2 steps for us, we reclassify basically everything that's less than 50 becomes a 0 because we can treat it as if it's uncontaminated soil. Everything from 50 to whatever the beyond the greatest number we're going to get gets a new value, and anything that is no data becomes a 0, so that any place we have a no data hole in our layer, it disappears. So for my first layer, my 0 to 3 layer, anything that's legally required to be dug up will get the value of 1. And I've given myself an output name that I can remember. In the 3 foot to 6 foot layer, no data becomes a 0. I'm giving it a value of 10, not a value of 1, because I want to add these 3 layers together, and I want to be able to tell where did I have a value over 50, what depth did I have that had a value over 50. So basically we're making a new category, and the category is dig or not dig. And if I have a 1 or a 10 or a 100, I'm going to dig it. And so for my third depth, my 6 feet to 9 feet, I'm going to put in a 100. And then at the end, I use raster calculator, and I just add these 3 together. Because I have a single-digit layer, a 2-digit layer, and a 3-digit layer. They don't really interfere with each other. They just accumulate into one grand total, which I gave the name excavate because that's what we're going to do. For each one of these tools, I am required to set the processing extent and raster analysis. So while using Modelbuilder speeds up some operations, you must be particular in making sure that you set all the parameters that are needed. Well, my model is completed, and I have the results of my entire analysis. The excavate layer probably needs a little explaining if you've not been reading along in the homeworks. Basically, each different category has a separate color on this map except 0, which will never be dug for any reason. I made that transparent. If we look at the 3 layers real briefly, we can see what's happening. So at 6 to 9 feet, that brown color has to be dug up. At 3 feet to 6 feet, the tan color has to be dug up. And at 0 to 3 feet, the brick red color has to be dug up. However, of course, in order to get to the tan color or the brown color, I have to dig through the top layer. So in the final steps of the analysis, we have to move a lot of uncontaminated dirt to get to these colored layers at different depths. And so that's where the excavate layer comes in. As we total up the different categories, we use logic to figure out which ones will be dug up and which won't. And that wraps up this process, I believe.